in brief. Piecewise functions. They are functions that are graphed in pieces. So that when I look at this function, this is one function, who we called f of x. He's defined as how many functions? 2. But each piece has its own set of x values. So it says as long as x is less than 0, it's x cubed. But if x is greater than or equal to 0, it's 3x plus 2. So what this does is it takes my graph paper and it breaks it into 2 pieces. One piece is going to be x greater than 0 or equal to 0. The other piece is going to be x less than 0. So essentially what you're going to have is one piece of graph paper with 2 graphs on it at the same time, in which the 2 graphs don't cross into each other's territory. It's kind of like what this essentially x equals 0 is a wall. It's in a wall between the 2 graphs. So the first thing that I'm going to do when I go to do one of these graphs is that I will put in the wall. And the wall is x equal 0. For x less than 0, I'm going to graph y equals x cubed. And for x greater than or equal to 0, I'm going to graph y equals 3x plus 2. One piece of graph paper, 2 graphs. There's a wall that's in between. One graph does not cross into the other graph's territory. It's kind of like me and my neighbor. Here's me, here's my neighbor, and my neighbor used to have hybrid wolves. What's the chance that I'm going to go over that fence that's between my yard and their yard, his yard, in order to cross into his yard? If there are 2 hybrid wolves on the other side. Slim to none, right? So that means that if I'm the graph here, I'm not going to be over there. Chomp. Now, when I had a dog, my dog was a little 10-pound terrier poodle. What was the chance he probably crossed? Although my dog was the only dog that was ever maced in the neighborhood by the postman. So who knows? He might be ferocious enough. But the chances of getting into my yard would be much better than that. So, but the 2 graphs are separate entities. If I look at the domain, this is your domain. That's your domain of f of x. So if I were to draw a number line, I have 2 graphs. There's 1, there's 2. Graph 1 says all x's that are smaller than 0. Graph 2 is greater than or equal to 0. What's shaded? What is shaded? Completely shaded. The whole number line, which is all real numbers. So the domain is all real numbers. So this is your domain right here. Range, I'm going to have to get off the graph. And then it says, okay, since we're playing with this for the first time, What is f of negative 1? Well, what yard did negative 1 live in? Negative 1 is smaller than 0, right? So f of negative 1 would use the which function? X cubed. So this would be negative 1 cubed or negative 1. So f of negative 1 would be negative 1. Yes. Oh, I've got the whole thing on there. Okay, that's good. F of 0, that means x equals 0. Which graph would he be on? The 3x plus 2, because it's the one that includes 0, right? So this would be 3 times 0 plus 2, which would be 2. So this one's on graph number 1, this one's on graph number 2. F of 1, that means x equals 1. Does he live on graph 1 or graph 2? Graph 2, because this guy is greater than 0. So he lives on graph 2. So this would be 3 times 1 plus 2, or 5. Now, there are a couple of ways of going after the x and the y intercepts. One is to get them off the graph, if you got the graphs correct. The y-intercept is easy. And why would I say the y-intercept is easy? Because the y-intercept means that x is 0. Do I know what graph x equals 0 is on? Yeah. It's on graph number what? 2. So the y-intercept would then say I'd have 2 or 3 times 0 plus 2, which is 2. So it would be x equals 0, y equal 2. So I know what the y-intercept is. Well, what about the x-intercept? Well, the x-intercept is where y equals 0. And I haven't a clue where y equals 0, because that's going to determine an x value. I don't know whether it's on graph 1 or whether it's on graph 2. Haven't a clue. It could be on both. Now, this is the only one I'm going to do this way, and then after that I'm going to say, just read it, give it to me, and approximate it off your graph. If y equals 0 off of number 1, this would say that x cubed equals 0, or x equals 0. Is x equals 0 in the domain of graph 1?
Yes.
Well, the domain of graph 1 is x less than 0. So is x equals 0 in the domain of graph 1? No. So not in the domain. So this guy, you'd say, nope. But this is the game you have to play, by the way, if you're going to do it algebraically. Well, let's see, graph 2. Do we have any x-intercepts at all? This says y is 0. 3x plus 2 equals 0. 3x equals negative 2. X is negative 2/3. Is negative 2/3 in the world of graph 2? No. His domain is x greater than or equal to 0. Is negative 2/3 greater than or equal to 0? No. So I have no x-intercepts. Now that's how you have to go about it algebraically. I'm not going to ask you to do that. I'm going to ask you just to read it off the graph. It's quicker, and I think about from an exam point, the viewpoint, it's quicker. So let's do one last thing. Let's graph in. And if I look at y equals x cubed, and I need 0, 0, 0. This is an open dot. It does not include 0, but I can get very close to it. I need numbers less than, remember, x is less than 0, -1, -1, and -2, -8. So 0, 0, -1, -1, -2, -8. So here he is, and then here is an open dot. That's why there isn't an x-intercept, because that guy is open. And for x greater than or equal to 0, y is 3x plus 2. I only need 2 points. At x equals 0, y equals 2, and it's solid. And if x equals 1, y equals 5. And that's his picture. That's what he looks like. First thing you want to do is when you're doing a piecewise graph, put in the wall so you know, and then mark which graph goes where. And it's one piece of graph paper, 2 graphs.